Welcome to the Arefco Service Group YouTube channel. Please remember to subscribe and ring that bell to get notified whenever we upload a new video. The importance of electricity in our modern society is often taken for granted. Without electricity, the heating, cooling, and refrigeration industries would never have advanced. Our industry relies totally on electricity to power and control the components that maintain comfort in our homes and offices. HVACR technicians need to understand the principles of electricity and be able to troubleshoot these circuits. So let's get down to the basics. All matter, everything that you see around you, even yourself, you're made up of atoms, the smallest quantity of a naturally occurring element. Atoms are made up of protons, which are positively charged particles, electrons, which are negatively charged particles, and neutrons, which are neutrally charged particles. Just like a magnet, like charges repel each other and opposite charges attract each other. Diagram A, this atom has 2 protons and 1 electron. It has a shortage of electrons and a positive charge. In diagram B, this atom has 2 protons and 3 electrons. It has an excess of electrons and a negative charge. Just kind of the opposite of the way you would think. Well, the movement of electrons, or the flow of electrons, is accomplished in 3 ways. We can move them chemically, magnetically, or with heat. A battery produces a flow of electrons by a chemical reaction between 2 electrodes within the battery. Batteries produce what is called direct current and is the flow of electrons in one direction only. Magnetic induction is the most widely used form of electricity generation. This is accomplished by rotating magnets within coils of wires. These magnets break the lines of force and cause alternating current to be produced. This method of electrical generation is what powers our homes. If you take 2 dissimilar metals and you join them together at one end and heat the junction, a small amount of DC voltage will be produced. The most common product in the HVACR industry that uses this is the thermocouple. So direct current travels in one direction. Negatively charged electrons flow from atom to atom, and they flow from negative to positive. Direct current is typically found in circuits powered by batteries. Alternating current continually reverses direction as the power source is changing. This is the most commonly used power source. The electron flow changes direction, and it is more economical to produce than direct current. Let's look at the units of measurement of electricity. Voltage is the electrical pressure or electromagnetic force. The difference in potential between 2 points is measured in voltage, and it is indicated by a V or an E. The V and E will become important when we get into Ohm's law in another video. Current is the amount of electron flow per unit of time. It's measured in amperes, amps or amperes, and is indicated by an A or an I. Watt is the amount of power used and is indicated by a W. Resistance is the opposition to electron flow. It's measured in ohms and indicated by the omega sign or an R. Good conductors have low resistance. Voltage readings can be taken across loads, switches, and power sources. Amperage readings are often taken with a meter that clamps around the conductor. Resistance readings are taken on circuits that are de-energized. In order to have a circuit, we must have a power source. This provides the voltage for the circuit. It can be either alternating current or direct current. There must be a load, and this is a device that uses the electrical power. It can be resistive or inductive, and conductors which provide a path for the current. So let's take a look at a simple circuit. Here we have a source, and we have our wires leading around to our load and then back to the source again. The source can be a battery, or it can be alternating current out of a wall outlet or from a panel box. So our source can be 1.5 volts, 3 volts, 9 volts, 24 volts, 120 volts, 240 volts, 480 volts, 277 volts, but there has to be a source. The pathway is the wire, switches, thermostats, and then the load can be a motor, a compressor, a light. It can be your computer, or it can be the HVAC equipment. Conductors can be solid wire or stranded wire. Here we see on the left is a solid wire. You have solid, in this case it's aluminum, surrounded by the insulation, and on the right you have stranded wire, which is multi-wires twisted together within the insulation. But it's handy to have a way to turn on and off your circuit, so we add a switch. Now a switch can be as simple as a simple knife switch, or it can be a wall switch. So let's take a look at how voltage is produced and how it kind of looks graphically. An oscilloscope will show you in a graphical configuration what electricity looks like. So let's take a look in what's called a sine wave. Here we have direct current, and it's producing 120 volts, and it's just a straight line. There's a constant 120 volts. There's no change in it at all. The sine wave graphically represents alternating current through 360 electrical degrees. It represents the voltage generated as a conductor is rotated within a magnetic field. It shows the peak-to-peak voltage values and the effective voltage, which is RMS, which stands for root mean square, and RMS value is equal to 0.707 times the peak voltage. Our peak voltage is 170 volts. The electricity coming out of the wall outlet in your home has a peak voltage of 170 volts, but if we multiply 170 volts times 0.707, it's going to give us approximately 120 volts, which is the RMS voltage, which is the usable voltage. With alternating current, because it is going from 0 to 170, back to 0, back to 170, and back to 0 again, it's going on and off what they call the frequency. It switches from top to bottom 60 times a second. We have a frequency here in the United States of 60 hertz, which means it goes through this up and down motion 60 times every second. The RMS is a way of evening out the voltage so that we know what our usable voltage is when we're talking about alternating current. So let's review real quickly. Electricity is produced magnetically, chemically, and with heat. Electricity can be either direct current or alternating current. An electrical circuit must have a power source, a load, a pathway, and although it's not necessary, it should have a switch as well. So that's it for Electricity, the Basics.